the zombie population continues to grow at the same rate. So now we're going to take a look back at our original problem, and we were growing at a rate, if you remember, of 50%. So our growth factor was 100% plus the 50%, which was 1.5. But this time we learned that there are 100 additional zombies locked up in an underground facility. So that's an additional 100 people that we weren't thinking about. So that would be adding 100. And if we recall from our table, we started with 14 people. On day 1, there was 21. So our equation this time would be our 14 initial people with a growth factor of 1.5x, plus now we have these 100 people that are locked up that will not be able to be infected. So now let's take a look at our domain. So our domain are all of our possible x values as we take a look at this. So keep in mind, x is representing our number of days, and we know that the world population is about 7.5 billion. And we also found out earlier that the number of days to reach that was right around 49 to 50. So a reasonable domain would be from 0 is less than x is less than 50. If we take a look at our reasonable range, which are our y values, okay, now our y values, if you notice, we now have this plus 100. So that's going to play a role. So even if we plug in 0 for our x value, for our number of days, we would get 14. 1.5 to the power of 0 is 1, so 14 times 1 is 14, plus 100 would be 114 is the smallest that value is able to go. Is less than y, and remember y is our population, so our population is that 7.5 billion people. So now when we look for our asymptote, remember asymptote is what the graph will approach along the y values, but it'll never actually equal that. And folks, in that case, our asymptote would be 100. Would be the imaginary line that it'll get really, really close to, but will never ever reach. What connection do you see between the asymptote and our equation? Okay, give the next one a go.